So in this portion, we will be talking about Cartesian equation of a line. Cartesian equation of a line can be formed from a vector equation of a line. So assuming my vector equation of a line r equal to a plus lambda d, which is equal to 1, 2, and 3, plus lambda 4, 5, and 6, where lambda is a real number. Now do note that this is a vector equation of a line. From here, what I'm going to do is we're going to try to form my Cartesian equation of a line. First off, we're going to let r be equal to x, y, and z. So over here, I can derive that x, y, and z will be equal to 1 plus 4 lambda, 2 plus 5 lambda, and 3 plus 6 lambda. From here, I can actually form up three equations. So x is equal to 1 plus 4 lambda, y will be equal to 2 plus 5 lambda, and z is equal to 3 plus 6 lambda. Once I get these three equations, I'm going to make lambda my subject for each of them. So lambda over here will be equal to x minus 1 over 4, and over here lambda will be equal to y minus 2 divided by 5, and lastly lambda over here can be z minus 3 divided by 6. And since all of them is equal to lambda, we can generally form my Cartesian equation of my line, which L is equal to x minus 1 divided by 4 equal to y minus 2 divided by 5 equal to z minus 3 divided by 6. Take note, you can actually see it in terms of this. So if my line direction is equal to L, R equal to A1, A2, and A3, where A1, A2, A3 represent the point that lies on the line, plus lambda, D1, D2, and D3, where lambda is a real number, essentially we can actually simplify it to this. X minus A1 divided by D1 equal to y minus a2 divided by d2 equal to z minus a3 divided by d3. You can actually memorize this, and this will help you to derive from Cartesian equation back to vector or from vector down to Cartesian quickly. However, you please do note that it's good for you to learn the manually deriving part, because essentially in exams you can actually help you to solve it if you actually forget how to entire memorizing form. Okay, so let's run back to here. We're going to try two different kinds of question. First, we're going to find the Cartesian equation of the line that passes through 2 points, 1, minus 2, 4, and 7, 2, 8. So from here, what I'm going to do is I'm going to try to form the vector equation of a line first. So I got 2 points, but I don't have any direction. So what I'm going to do is I'm going to create the direction of this line by taking 1, minus 2, 4, minus away 7, 2, and 8. So this will give me minus 6, minus 4, and minus 4. Same thing, because this is the direction of the line, we can actually simplify further by taking out minus 2. This will give me 3, 2, and 2. So my vector equation of my line essentially will give me this. R equal to A, which is 1 minus 2, 4, plus mu 3, 2, and 2, where mu is a real number. From here, we can actually quickly form the Cartesian equation of the line. If you can't remember the memorized form, do make the manual method by making lambda the subject. If not, essentially you can derive it very quickly to be this. X minus 1 over 3 equal to y minus 2 over 2 equal to z minus 4 over 2. So to further simplify, you can actually rewrite the line equation to be this. Next, we're going to touch on the second example. Second example, given me a line equation. So L, R equal to 1, 2, 1, lambda 1, 0, minus 3. Take note, because of the 0 over here, I can't actually make y minus 2 over 0, because I can't divide anything by 0. So from here, how do I do this question is, I can actually quickly launch back to my manual method. So I'm going to let R be equal to x, y, and z. Okay, take note, this is a part 2 question. So x, y, and z essentially will give me 1 plus lambda, 2, and 1 minus 3 lambda. So x will be equal to 1 plus lambda, y will be equal to 2, z will be equal to 1 minus 3 lambda. So same thing, I'm going to make lambda my subject. This will give me x minus 1. Y I can't make lambda a subject because there's no lambda. Then essentially z over here will be z minus 1 divided by minus 3, which is equal to lambda. Okay, so I can actually create my line equation. Okay, since only x and z value have lambda, I equate two of them first. Okay, z minus 1 divided by minus 3. And because y don't have, I put a comma, y is equal to 2. So if you see a Cartesian equation of line having a comma, where x is equal to something, y equal to something, or z equal to something, essentially it just means that the direction value at the x, y, or z component is essentially 0.